So this question is the one, right, where you will need to know this idea. So I write the idea first. So if it's an increasing rate, the curvature will be like this. If it's a constant rate, it will be a straight line. So later on, under question 18, we also got the same logic. So that's why I give you the same generic idea first. So increasing rate, constant rate, and a decreasing rate. So these are the three curvature that you actually need to memorize. Okay, so this one will be valid for the speed time graph later, speed time graph that we are going to do in question 18. So how do you approach this kind? You got to find out the volume. So if you look at the description, you got to find out the volume because we fill up according to the volume and it takes 88 seconds. So some of you, right, I think at least you try, but you realize your answer is very weird, correct? So did you do it by the volume? Okay, so you got to observe the volume. So what I did was I found out the small pyramid first. So this is a small pyramid. So this is L, and then this is H. So I found out the small pyramid, which is this one. Okay. I also found out the big pyramid, everything here. The big pyramid is the one that is like everything. So if you look at the big pyramid, it is 2H. That's why you look at my working. So I make use of the pyramid formula, but then I realize it's like this. Okay, after that, I got the cuboid that they insert in between. So this is a cuboid that they insert in between. So you can tell that it's a L here, and then this part is a H. So I calculated the cuboid so that I can know the total volume. The total volume will be the big pyramid, which is the whole blue color. The whole blue color is split into these two. These two are the big pyramids. So I found out the total volume. I found out the total volume by adding the huge pyramid and the cuboid. Then you might be thinking, then why do I find the small pyramid? I'm finding the small pyramid later on for this part. Okay, but I found out the total volume first. So I found out the total volume. So in a way, this is the one that takes 88 seconds. So the total volume is the one that takes 88 seconds. So how much time will it take to reach this height? So this is the volume I need to know. So this is the volume of the small pyramid. So if you prefer to do the primary school method, right, you can do something like this. So if you are the kind who prefer primary school method, then you can think this way. So that means L square H is 24 seconds. And the small pyramid here, this is the small pyramid. The small pyramid is 1/3. So it will be 24 times 1/3, which is 8 seconds. Can see? Then how much time does it take to reach 2H? So how much time does it need to take to reach 2H? Then you got to calculate the volume here. So I got to calculate the volume of the cuboid and the small pyramid. So that's what I did. So if by the time you hit 2H, so how much time you will need? You do the same thing. but you add up the cuboid, you add up the pyramid. So if you add up, right, it will be a 4/3 L square H. So 4/3 L square H will be quite easy. You multiply 4/3 on both sides. That's how you get the 32 seconds. So we are filling up the container in terms of their volume. That's why you should have explored the volume first. If you're thinking, how do you get started on this question? And subsequently, with all the volume and your answer. So just now, right, we realized that, okay, this will take 8 seconds. So you plotted a point. And 2H will take 32 seconds. So you got another point plotted. Eventually, you'll be 88 seconds. Then you should explore increasing or decreasing. Then you should explore whether is it increasing or decreasing. So if some of you are not so good, right, you can think about thinking it this way. You try to pour in water. You will find that the initial part is very fast. You try to top up the water here. So you try to top up the water. The initial part is very fast because it's just a small volume, but you will get slower and slower. So if you take a look, this one will be decreasing. It will get slower and slower because initially it was very easy to fill up. Initially, it's just a tiny dot to fill up, then it gets bigger and bigger. So that's why I'm using the decreasing curvature. And then subsequently, the cuboid is a layer. Each layer is consistent. So every layer is the same amount. So for a cuboid, it's a constant rate. So it should be a straight line. Then subsequently, the last part starts quite small and eventually it gets bigger. So it again is a slower rate. So this one is decreasing. And then this part is also decreasing. So I'm using the decreasing curvature. And then the middle part, I'm using the constant curvature. So it comes down to the idea of increasing, constant, or decreasing. And it also boils down to calculating in terms of volume. Okay, so you have to take note of this. You don't see a lot of such questions. So I think, Chotin, do you do this kind of thing? I vaguely remember, don't know who is the one. The teacher actually spent quite a bit of time doing this in school. Or is it my past students? So anyway, you don't see a lot of these questions. So I will be giving you maybe just a couple more questions on this to practice. But it comes down to these 3 rates, which I'm going to use it for question 18.